Ganesh bhai.
ನಮ್ಮ ಇವರು 4 ಮೆಂಬರ್ಸ್ ವಿಡಿಯೋ ಆಡಿಯೋ ಆನ್ ಇರಬೇಕು. ಆಡಿಯೋ ಬೇಕಿದ್ರೆ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲಾಂದ್ರೆ ಅವರಿಗೆ
Audio. Good morning, all participants. We will start the session within 10 minutes. Hope you can. It is the sound is audible and audio video is visible. Ansari sir, we'll start.
Okay,
Good morning, sir.
good morning.
So,
Shall we start, sir?
Am I audible?
yes, sir, yes.
Okay.
A very good morning to one and all. I, Professor Muhammad Hafiz MK, Department of CSC, welcome you all to the second day of online short-term training program on machine learning for societal applications. Before we begin with the today's sessions, I would like to kindly remind all participants to mute your audio and video for the smooth flow of the program. So session details are, so we'll be starting the session from 9:30 to 4:45 in the morning session, and we will have a break from 10:45 to 11:15. After that, we have 11:15, we'll resume the session till 12:30. So 12:30 to 1:45, we have a lunch break. Then sharp 2 will start and it will continue till 3:45 p.m. From 3:45 to 4 p.m., we will have a question and answer session. So if participants are having any queries, you can drop the questions in the chat box. It will be conveyed to the speaker at the end of the session by our coordinators. If there are several queries, the answers will be mailed to all the participants. Attendance link will be shared in every session in Zoom and YouTube chat window only, and participants are requested to submit your attendance. With this short summary of today's schedule, we shall now commence our morning session. So to begin with, I am honored and privileged to introduce the most eminent and distinguished speaker of day 2 session, Dr. Zaid Ahmed Ansari, Professor, Computer Science and Engineering and Dean Research, PA College of Engineering, Mangaluru, to our participants. Dr. Zaid Ansari started his engineering educational career in 1984 when he joined 4-year sandwich pattern diploma engineering course in industrial electronics at SBM Polytechnic, Mumbai. In 1988, he completed the course with 1 year in plant experience from Electronic Division Research Lab at Baba Atomic Research Center, Mumbai. He obtained his BE degree in Computer Science and Engineering from Government College of Engineering, Aurangabad in 1991, securing 3rd position in the university. He performed his final year project at MIS division of Bajaj Auto Limited, Aurangabad. After completing his BE, he worked as a lecturer in the Department of Computer Science, Pune College, Pune for 2 years. He obtained his ME in Software Systems degree from Birla Institute of Technology, Pilani, in 1995, securing 2nd rank in the university. In campus interviews, he was selected by 2 leading software companies, namely Wipro Systems and Tata Consultancy Services. He joined Tata Consultancy Services, Pune, as a software engineer and worked on the development of cutting-edge software modeling tools. During his 12 years long association with TCS, he has been engaged in various assignments in India and abroad. He was deputed by TCS as an IT analyst to GE Harris Railway Electronic, Florida, USA for more than 3 years from 1998 to 2001. He was also deputed to United Services Automobile Association, San Antonio, Texas, USA as a software consultant for 6 months. While on deputation, he also completed 2 PhD level advanced courses from Florida Institute of Technology, Melbourne, Florida, USA, securing 1st rank in the class with CGPA 4 on 4-point scale. During 2002 to 2007, he was associated with Tata Research Design and Development Center and worked with the research team in developing model transformation technologies for model-driven architecture. He received an award by TCS for continuous commitment and excellence in recognition of his dedicated service to the organization. Dr. Zaid Ansari received his PhD degree from Jawaharlal Nehru Technological University, Kakinada, for his thesis titled Data Mining Using Soft Computing Techniques. Since October 2007, he is working as a professor in Department of Computer Science and Engineering, PA College of Engineering, Mangaluru. Since 2015, he is also serving as the Dean Research in PACE. Dr. Zaid Ansari has published 3 books and 80 plus research papers in various international journals, including ISI and Scopus Index journals, with impact factors and proceedings of international conferences of repute, including IEEE conferences. Some of his papers were selected for Best Paper Category Award. Number of citations to his papers have exceeded 350. He received VGST CICEE research grant of rupees 30 lakhs for the establishment of the High Performance Computing Lab, and currently he is supervising 6 PhD research scholars. He is a reviewer of International Journal of Information Science, elsewhere publications. He is a member of Association for Computing Missionary and a lifetime member of Computer Society of India. His current research includes data mining, web usage mining, soft computing, high performance computing, and model-driven software architecture. With this short introduction, I wholeheartedly welcome our today's speaker, Dr. Zaid Ansari, sir. I welcome you, sir.
Thank you, Officer.
So without further delay, I request Dr. Zaid Ansari, sir, to start the session. So over to you, sir.
Okay. Officer, am I audible?
Yes, sir.
Okay. Good morning, everyone. I welcome all of you for today's sessions on the clustering techniques. Yesterday, you had wonderful sessions about the introduction to the data analytics and machine learning. And you had even one hands-on session for machine learning using Python. Today, we'll be having 3 sessions as discussed by Hafiz sir. In the first session, I'll try to cover about the clustering, its applications, how to perform clustering using the similarity measures. Then, if we want to perform the clustering using R language, then how to install and use RStudio, and how to do the preliminary data analytics on the data. Okay, this I'm expecting to be done in the first session. I hope the time permits us to complete this. In the second session, I'm planning to go with the various clustering techniques, starting with the partition-based clustering. In that, I'm planning to cover K-means clustering, K-medoids clustering, its variations, PAM, Clara, etc. Okay, and its demonstrations. And if the time permits, then fuzzy C-means clustering too. And in the afternoon sessions, then we'll go to the other kinds of clustering, like hierarchical clustering, density-based clustering, and model-based clustering if the time permits. Okay, so let's see how it goes. Okay, so with this brief introduction, let me start this session. Okay, so I'm sharing the screen. Hafiz sir, is my screen visible?
Visible, sir. Visible. Sir.
Okay. So agenda for the session 1 is, I'll be starting with introduction to the data clustering. Then we'll go into the application areas. I tried to bring the application areas in various domains, and the idea was if the research scholars who are there in these sessions, at least if they want to pursue their research in the field of data clustering or the data analytics, then maybe some of the areas might be of their interest. So just to tell that, where are all the areas where data clustering can be used? Okay. Then the basis for the clustering is how to measure the similarity between the objects. So that will take in detail what are the various similarity measurement techniques are there. Then we'll discuss about the broader categories of the clustering methods. Okay. Once we do this, then we'll come to the R software tool. It's installation, quick installation, and how to use the IDE for the R software tool that's called R Studio, and how to use it for the data analytics. Then some preliminary data analytics will be doing on this. Okay, this is what is the agenda in front of me for this first session. Okay, yeah, okay. So we all know that we are in the age where there is a rapid growth of data, and data is coming from various sources. We have huge legacy documents. We have multimedia data. Every individual is having his or her own data in the form of multimedia. Pictures are there, videos are there, sounds are there. We have the cloud where the big organizations, they are keeping their data, right? Web is maybe the one of the largest source of the data, heterogeneous network of the data. Internet of Things, through this, we are connecting every object. We are trying to connect every object to the internet. We want to connect to the buildings. We want to connect to the houses. We want to connect to the hospitals, right? To the vehicles, right? So through the internet, we want to control everything. All that data that is being gathered. Big organizations, they have their own data, social media, Facebook, social media networks, right? Then the various activities what the user perform on the web, those activity logs are getting generated. Big data warehouses are there. So due to these various data sources, there's a rapid growth in data, and currently in 2020 the world data size is 35 zettabyte, and zettabyte is too large. We know the gigabyte, usually our hard disk, or maybe terabyte, our hard disk is in that, right? 1000 terabytes is petabyte, 1000 petabyte is exabyte, 1000 exabyte is zettabyte. So we have huge amount of data. So we need the data analytics, and that is the process of examining data sets in order to draw the relevant conclusions about the information they contain. And one of the very important data analytic tasks is the data categorization. We also call data classification or data clustering with some differences. Okay. So, and it's not new for us, the data classification. As kids, we used to perform the classification of given items, like we were given these items and we were trying to classify it. Okay. The basis of classification was different. Sometimes we used to classify it or group it by shape, all the squares together, all the circles together, all the triangles together. Sometimes we used to classify it by color, okay? Green color objects, okay? Yellow color objects, like that. When we learn more about the geometry, angles and all those, so based on the internal angles, right? Some of the internal angles, then we used to classify them, okay? So there are various bases for the classification. The classification, it consists of assigning a class label to a set of unclassified data object or cases. So we have a group of data objects and we need to find out the label of it's a class or it's a category. It belongs to which category? Then there are again two cases: supervised classification, unsupervised classification. What is supervised classification? When we know the categories, when we know the name of the classes, these data will go to these classes. Name of the classes is known. The set of possible classes is known in advance. Then we say that it's a supervised classification. And we do not have any idea about the classes. What are the classes? How many classes? Right? We just have the information about the objects, their characteristics, attributes, and we do not know how many classes are there, what are the classes are, and what are the names. That is unsupervised classification. Okay. So in supervised method, we have the data, and the datas, they have the categories. So see here, we have various objects are over there. We know their categories, right? What is the category of this, and what is the category of this object? What is the category of this object? We have the label on that. But in case of the unsupervised classification, we just have the data. We do not have their categories. See, we have so many cat objects over there. We do not know anything about the cat categories over here. Okay. So here, whatever classification we'll be doing, that will be unsupervised classification. Okay, let's take an example. Okay, consider the table over here. Table is containing the marks obtained by a set of students and their corresponding grades. Okay, so some marks are there over here, right? And the grades are there, student roll numbers are there. Then here there is a figure, right? Over here. In this, the classification is done. And this grouping is based on the grades. We know that there are the classes. How many classes are there? A is there, B, C, excellent, all these classes are there. Okay. So we know these are the classes. So based on the marks and based on this labeling, they are grouped over here, right? So basically the ones, number 5 has the B grade, right? Similarly, 12 has the B grade, 15 has the B grade, they are grouped over there, right? Similarly, roll number 11 is fail. These, they have the excellent grade category, like that we have. This is basically the supervised classification over there. On the other hand, let's say if we have the data like this, we just have the roll number and marks, and we do not have any information about the grading over there. Okay. So then how we'll be doing the classification? So here one process is shown over here. Put all the marks into a group. If any other mark in that group does not exist, exceeds by 5 or more. Okay. So we start with the minimum 25. Okay. The next one, it is more than 5 over here, 35. So it will go into a different group. 40, just the difference is of 5. It will remain in the same group. 45 will remain in the same group. 50, 55, right? 50, 55, all this. 65, again, it's exceeded. It is more than 5 marks over there. The difference between 65 and 50. So it will go into another group, right? So basically, so this grouping is accomplished by finding similarities between the data according to their characteristics. So we are taking this mark as the characteristic of it. Based on the marks attribute, we are classifying them, right? So such grouping where we do not have any idea about the various categories, this is basically the clustering. Okay. So what is clustering? Clustering is a way of grouping together data objects that are similar in some way, according to some criteria that we pick. Okay. Depending on our subject of the data analytics, we have to pick what are the characteristics of the object based on which we want to categorize them. Okay. So it is a form of unsupervised learning. You generally don't have examples or the labels demonstrating how the data should be grouped together. It's a method of data exploration, a way of looking for patterns or structure in the data. We want to see the similarities, the similar ones we want to put into a cluster. The dissimilar ones we want to separate. Okay, so we are trying to extract a pattern or structure from the data. So it's basically organizing the data into classes or groups such that each class or group, it has high intra-class similarity. We want that within the class, the objects should be very similar to each other, and low inter-class similarity. Different groups should be very different. Object in different groups or different classes should be very different from each other. We want to find the class labels and the number of classes directly from the data. In contrast to the classification. In classification means supervised, unsupervised classification. There we have the class labels. Clustering is unsupervised classification. We do not know any class label in advance. We try to find out the class labels and the number of classes directly from the data. More formally, finding the natural groupings among the object. Okay. So what is the clustering definition? Given a set of data points, each having a set of attributes and a similarity measure among them, find clusters such that data points in one cluster are more similar to one another and data points in separate clusters are less similar to one another. Okay. So let's see, we have the points over here. Okay. So now we see these are the clusters of the data. So intra-cluster distances, they are the minimized. We want to group them in such a way that, okay, intra-cluster distances, they are minimized, and inter-cluster distances, they are maximized, right? So inter-cluster distances, they are maximized, right? If these are the groupings, 1, 2, 3 groupings are there over here, okay? So intra-cluster distances, they are minimized, and inter-cluster distances, they are maximized. Why clustering is required? Okay, let's consider a problem. You have 10,000 customers. You know their age, city, income, employment, status, and designation. You have to sell 100 BlackBerry phones, very expensive, $1,000 cost, to people in this group, to these 10,000 customers. Within 7 days, you have 7 days time, and we have to sell 100 BlackBerry phones. If you start giving demos to each individual, how many individuals are there? 10,000 individuals are there. It will take more than 1 year. How will you sell maximum of the phones? By giving minimum number of demos? Okay. So for this here, okay, you need to categorize, or you need to cluster the customers into 2 groups. First, let's say the employed, unemployed, because you have the information about their age, the city, income, employment status, designation. These information, these are available to you from the customer database. So the solution is you have to categorize the customer into 2 groups, employed, unemployed. Okay. So let's say 10,000 customers are there, and you, after categorization, you found that 3,000 unemployed, 7,000 employed. Then further you have to categorize, right, the employed customers into 2 groups, high salaried, low salaried. Okay. So again, you categorized it based on the criteria, salary criteria. Okay. So you found low salaried 5,000 and high salaried 2,000. Okay. This is again a big scope over here. So you further categorized it, the high salaried customers, based on their designations. Lower designation, higher designation. Okay. So when you did the higher designation, okay, you found like 200 customers. Now these are your market target. You can work on them in 7 days. You can try to give the maximum demos to them, and you get your work done as much as you can. Okay. So this is one of the place where it can be used. So we'll be looking at the various application areas for the clustering. So as I discussed, clustering is used a lot in business, market segmentation, market research. We'll be seeing few more applications soon. Okay, to solve the social problems for geographical clustering. Okay, in the environmental and geographical domains, for the information discovery, to create biological taxonomies in bioinformatics, outlier detections means to detect the cases which are abnormal, which are very different from the normal cases. Image segmentations, these are the few areas over here. Okay, we'll be taking the details one by one. Okay, let's look at business and market research. Okay, so like we saw this problem, whenever you have anything, so you want to find out, you need to divide your customers in various segments, right? So market researchers, they use cluster analysis to partition the general population of consumers into market segments to better understand the relationship between different groups of consumers or potential customers for use in product positioning, selecting test markets. So grouping the people according to their similarity, their purchasing power, willingness, authority to buy. These are the certain areas. So the areas can be the areas based on which you want to divide your customer may be geographic, the customers who live in the cities, in the villages, in the towns, or maybe in Maharashtra, in Karnataka. Okay, behavioral. Okay, they're, if they're accessing the web, their web access patterns. Okay, demographic based on various criterias, right? Their education or their income, and maybe various criterias over their maybe their caste or various things. Okay, then psychographic. So basically, depending on the personality of the function, the person, like that. So there can be various criteria based on which you want to divide your customers. So for all this, which will be very useful in business and market research, you can use the clustering. Recommendation system. We all know that when we'll go to Amazon or Flipkart or maybe the other places for purchasing, and we try to purchase one item, they immediately give us that the people who purchase this, they also purchase that. If you purchase a book, they'll recommend another book, right? If you purchase a computer, they may be giving some accessories or something to you. How do they do it? Basically, they cluster the profiles. So their customers, they come, right? Based on the characteristics of the customers, they cluster them. Okay. So let's say here there are three clusters, right? One cluster, they found of the people who are interested in sports, right? Then one cluster of the girls who are interested in certain kinds of video games. Another kinds of clusters of boys who are interested in another kinds of video games. Okay. So when a new person comes, then they try to fit it into it is, if it is closest to this cluster, then they'll recommend these kind of things. If the characteristics of that person is closest to this cluster, then in that case they will offer this. So this for the recommendation system. So clustering is also helpful in recommendation system. Okay, grouping of the shopping items. Clustering can be used to group the shopping items available on the web. Okay, let's say eBay items can be grouped into the unique products. So based on the similarity of the clustering can be applied in order to cluster various items into the products. So this we saw about the business and marketing. Okay, related to information retrieval, document categorization, and natural language processing. Okay, when we do the Googling, we search, right? So at that time, right? So basically, when you search, So related to the keywords, lots of documents, they just come up. Sometimes they're in millions in which those terminologies, they are there, right? So how does Google and the other search engines, they decide about it? What they do is they they categorize the documents based on the search terms and all those, okay? And among them, they also use the site ranking to know which are the most popular, and they return it, okay? So for the efficient search result, even the clustering is required. Document categorization. Okay, imagine you are limited in time and need to organize the information held in documents quickly. You have lots of documents. To be able to complete this task, you need to understand the theme of the text, compare it with other documents, and classify. You have lots of documents, you do not know anything about them, and you need to categorize them, right? So you need to see what are the terminologies used. Clustering technique can be used to solve this problem. It will look at the text terminologies and group it into different themes. Using this, you can cluster and organize similar documents quickly using the characteristics identified in the various paragraphs of the documents. Natural language processing. In NLP applications, clustering techniques can be used to categorize the semantically similar words or sentences. Okay. So based on the semantics of the sentences and the words, they can be categorized into the groups, and that may help in resolving the lexical ambiguities. Okay. So this is also one of the application. Anomaly detection, outlier detection. As I said, in this case, we want to find out the odd cases. Okay. So if you see here, okay, so many eggs are there, and this egg is very different from all other eggs. So this is basically outlier or some abnormal case over here. So many fish over here, and this fish very different color, direction is also different. Okay, this is very different case from all others over here. How do you do that? When we cluster the data and we find that there are the points which do not lie in any of the cluster, so probably they are the abnormal cases. There's something wrong with them, or they have some exception in them. Okay, so clustering can be used for anomaly detection. For example, you want to use clustering for credit risk analysis. Okay, so you have so many customers. Okay, so basically the banks or maybe other financial organizations, they do the study of the credit risk analysis before giving loans to their customers over there. Okay, so let's say one such analysis is you know about the customer, right? Whether yeah, the loan and salary, based on that, you have plotted them over here. And let's say you got two clusters over here. Okay, these are the higher salaried uh, customers. Okay, these are the low salaried customers. Among high salaried customers, see most of them, see here the red cases, those who did not pay the, repaid the loans. And the blue ones, they have repaid the loans, okay? So the high salary customers, this cluster over here, there are few cases which have which have not repaid, okay? So they are different from the others over here in this particular respect, okay? So through the clustering, finding out such things, the abnormal cases, this can be used for the credit risk analysis. Similarly, classifying the network traffic. Imagine you want to understand the different types of traffic coming to your website. You are particularly interested in understanding which traffic is spam or coming from the bots. You want to be able to block the harmful traffic. Okay, so basically you want to classify the basically the traffic sources you want to classify the traffic sources. Okay, so based on the characteristics of the traffic sources, you need to identify, okay, from which traffic sources basically you are getting the harmful traffic. Okay, so through the clustering, maybe it may lead to you to identify the traffic sources from which the harmful traffic comes. Fake news identification. Students at the University of California, Riverside are using the clustering algorithms to identify fake news based on the contents. They take the content of the fake news article, the corpus, they examine the words used, and then they cluster them. Okay. These are the clusters, what they help their algorithm to determine which pieces are genuine and which are fake. How? Certain words are found more commonly in sensationalized clickbait articles. So the fake news, they have the sensationalized clickbait articles in that certain terminologies, they are appearing very prominently. Okay, so from this clustering, the ones which are having the high percentage of this, okay, so such groups can be identified that this news is the fake news. Similarly, the spam filtering, okay, you have the mail, right? Depending on the contents of the mail, right? Heading and the body and the various parts of the mail, and then identifying the keywords from there, right? It is identified that which are the genuine mails and which are the spam cases over there. Biology, bioinformatics, chemistry, medicines, this is a huge application area for the clustering. Okay. Plant and animal ecology, right? Cluster analysis used to generate artificial phylogenesis. So here, see among the animals, okay, let's say we want to classify the finch bird based on the various characteristics. So clustering has been used to classify them. Similarly, to classify, to generate the phylogenesis for the plants, the clustering is used, is one of the application. In bioinformatics, the sequence analysis is done, right? They have the genomes, they have RNA sequences, they have the protein sequences, they have the DNA sequences. They want to know about the various organizations. There are these sequences, the genes, the expressions, right? So sequence clustering is used to group homologous sequences into gene families. Transcriptomics clustering is used to build groups of genes with the related expression patterns. Okay. Human genetic clustering. Okay. Human genetic clustering is a cluster analysis of the degree of similarity of the genetic data between individuals. So this study is also being done. So basically, based on that data, the clustering, the Native Americans, Eastern Asians, okay, African Americans, like this, it is based on the human genetic clustering data. Then in medicine, classification of the antibiotics, cluster analysis can be used to classify antimicrobial compounds according to their mechanism of action, or to classify antibiotics according to their antibacterial activity. Okay. In chemistry, to find the structural similarity between the chemical compounds, the clustering can be used. Okay. Image segmentation. Again, in the medical field, cluster analysis are being used to differentiate between different types of tissues in a 2 or 3 dimensional medical images for various different purposes. In this figure, basically, the image segmentation, it is done to identify the brain tumors over here. So see here, the tumors are being identified over here, right? So it is basically segmenting or the clustering the pixels, right? Image segmentation is done based on the similarity of the pixels over here. Image segmentation is also done for object detection, border detection. Okay, so clustering can be used. right? Over here. So you can detect this is cat and this is duck, this is dog, this is car, okay? Even from the videos and from the images, okay? Then from the images to find out the borders, right? So this is the border for this cat using various kinds of clustering techniques, okay? Similarly, for various other sleepy map optimization based on the geographical characteristics, grouping them. Okay, so we want to reduce the markers over here for the sleepy map optimization over here. Okay, then for lots of social problems. Okay, crime analysis. So cluster analysis can be used to identify areas where there are greater incidences of particular types of crime. Okay, so let's say through this clustering, the hot areas of the crimes, they are identified over here. Okay, they may help the law and order maintenance teams to do that based on the clustering. Okay, then other societal problems, educational data analysis. Okay, you want to work on in the society, like how are the you want so clustering can be used, so you can identify these are the high income low moderate education people, these are the moderate high education low moderate income people, these are the moderate education low income middle aged people, like this. Okay, so education or economical or maybe literacy, whatever, in different areas you can do the cluster analysis. Okay, social network, that is a huge ground for the cluster analysis, right? So you can identify like the various clustering group, you can recognize the communities within the larger groups of the people over there, friends, family, high school local area friends, like that. Okay, and that can, this information can be used for various purposes. Then geographical environmental applications. Okay, in Finland, the municipalities were classified into three groups based on the land use. Okay, the land use, how much of water is there, what is the agricultural area, okay, how is the traffic and infrastructure, industry and residential areas, how the land is used. Based on that, they have classified their municipalities. Okay, so depending on the objective of the study, you can do the you can classify the areas geographically. Geochemistry, soil samples were collected from 66 sampling locations from the Long Island in New York, one of the areas of the New York, at three different horizons. Then clusters are formed. Okay, four categories of the clusters are formed. Okay, according to their substrate utilization pattern. Okay, so basically, you can cluster the geographical areas, or based on various, here samples of soil samples are taken for the purpose of the classification or the clustering, geochemistry. Climatology. Okay, so for the climate studies, clustering techniques can be used to find out the weather regions, climatic zones, right, atmospheric patterns, right, in India, similar climate zones, right, over here. Okay, similarly other parts. Even cluster analysis has been used to find the abundant areas which are suitable for the construction of the solar power plants. Okay, so these are some of the applications. Okay, I took it in detail so that maybe some of the participants might be looking for finding out an area where they can apply their machine learning or data clustering research. Then any of these can be selected for this. Okay, okay, once we know about the application areas, how to proceed, how does the clustering work? So the primary objective of the cluster analysis is to define the structure of the data by placing the most similar objects into groups. Okay, but how will you find the similar objects? What attributes to use for clustering? And the most important is how to measure the similarity, right? How you will measure the similarity. These two objects, they are similar or they are dissimilar, right? Then how to form the cluster, then how many clusters, various questions are there, okay? So first we'll take how to measure the similarity, okay? Sir, cell phone, may I know the time? So we'll look at how to measure the similarity, okay? So basically, we want to find out, let's say we are given a set of objects over there. So we want to group them, right? So what will be the natural grouping for them? What will be the criteria for the grouping? Or what should be the basis for grouping them based on their similarity? So let's say we have these many objects over here. So basically clustering, it is subjective. There can be various criteria. Okay, let's say here we are clustering, let's say the family, whether they are related to each other, relative to each other. So we found out one cluster, Simpson's family, okay? Or those who are working together, so school employees over here. Or based on, let's say, their gender, so female objects and the male objects. So right, it is subjective. What is similarity? So you see here two pictures. Are they similar? So according to the Webster's dictionary, the definition of similarity is the quality or state of being similar, likeness, resemblance, as a similarity of features. So similarity is hard to define. We know it when we see it, okay? When we see it, we know it that maybe they are similar or not. But we want this to be done by the computer, okay? So how to do it? So we need to find out the similarity between the objects or the similarity between the objects, okay? So let's say here we have these two animals and we need to find out the similarity. So we need some function or some method to find out the distance between them. Let's say some method is used over here and we found that their dissimilarity is 0.23. Then these are the two words, right? Peter and Powder. We want to find out dissimilarity between them. Or we have the fingerprints. So objects can be of anything, right? They can be images, they can be text, they can be pictures, they can be records, etc. Okay, we want to find out the dissimilarity between them. Okay, so similarity and dissimilarity. In clustering techniques, similarity or dissimilarity is an important measurement. Similarity between two objects. It can be two images, two documents, two records, is a numerical measure of the degree to which the objects are alike. Dissimilarity, on the other hand, is a measure of the degree to which the two objects are different. Both similarity and dissimilarity also terms as proximity. So we use proximity, basically how close they are or how far they are. Okay. Usually similarity and dissimilarity are non-negative numbers and may range from 0 to some finite or some very large values too. Okay. Frequently the term distance is used as a synonym for dissimilarity. Okay. So let's say we are having the objects. Now objects, they are characterized based on the various kinds of attributes. The attributes can be the nominal attributes, they can be the numerical attributes, salary, okay, some numbers they are there, right? Nominal attributes, gender, okay, here some names are male, female, okay. If the nominal attributes, they have the two values, then we call the binary nominal attributes. So here gender is the binary nominal attributes. Let's say the object has a single nominal binary attribute, okay. So how many objects are here? John, Jill and Jack, okay. Their gender, they're given over there, okay. Okay, let's say we assign, since it's a binary, so one we have to give the one name we have to give the value 1, and another name we have to give the value 2. So let's say male we are giving 1 and female to 0 over here. Okay. So similarity between two objects ij is 1 if the two objects I and j, they contain the same attribute value. Okay. Either both are 1 or both are 0, then their similarity is 1. Okay. If they differ, then their similarity is 0. Okay. So John and Jill, okay, John and Jill, okay, their gender is different, so their similarity is 0. And John and Jack, their gender is same, so their similarity is 1. So once we know the similarity, dissimilarity is basically 1 minus similarity. Okay, 1 minus similarity is basically the dissimilarity over here. Okay. Okay, let's say we have the multiple binary attributes. We have the multiple binary attributes. Okay. So how to calculate the multiple binary attributes? Then in that case, basically we take the numbers. F11 is the number of the attributes where both have the value 1. See, when there is a binary, we'll give one of the value 1. We'll consider one of the value 1 and the other value is 0. So if both, how many like attributes are there where both of them, they are matching in 1? And how many attributes are there where one object is 1 having the value 1 and other is having 0? And the first one is having the value 0 and the second one is having the value 1, and both are having the value 0. So we have F00, F01, F10, F11, right? All total is the count of the number of attributes. So B is the number of attributes over here. Okay. So how to find out their similarity and dissimilarity? Now, if these binary attributes, they are the symmetric. What is the meaning of symmetric binary attributes? Let's say gender. So male, female. Okay. So normally they are symmetric. Like there is equal probability of being male, female in most of the areas over there. Symmetric. Then we deal it differently. And there's some other cases where the two values, they are very different. For example, for a patient, let's say COVID positive, COVID negative. Okay. So generally it is COVID negative. COVID positive is very, very different, right? So they are not symmetric binary. They are asymmetric binary. So symmetric binary, asymmetric binary, they are dealt differently. So if it is symmetric binary, then in that case, the similarity between two objects ij, it is measured based on the number of matching attribute values divided by the total number of attributes. So F00 plus F11, both are matching on 0 plus attributes which are matching on 1 value divided by the total number of attributes. And dissimilarity is basically 1 minus that, right? All the attributes which are not matching, right? Attribute values which are not matching divided by the total number of attributes. But when it is okay. There's an example which I'm leaving now. Okay. Asymmetric binary attributes, in that case, here we give the importance for the case which is unusual. Let's say COVID positive, we'll give it like 1. Okay. COVID negative, we'll give the value 0. So if there are two objects, we want to find out, okay, like how many which are having attributes, they are matching on the unusual cases. How many attributes matching on unusual cases divided by the total number of attributes except the number of the usually matching cases. So 0, we don't care. So from the denominator, we take out that. Okay. So this is called the Jacob coefficient. So if the attributes are nominal, okay, binary, single or multiple, we can use this. Okay. Yeah. Okay. Let's say the attributes are categorical. What are the categorical attributes? Okay, let's say color of the person, red, green, blue. So basically they have 3 or more values. 2 values we say binary, right? 3 or more values. So red, green, blue. Okay. How do you measure them? So here it is simple. 2 objects are there. we see the number of matches divided by the total number of attributes, and dissimilarities, number of the mismatches divided by the total number of attributes. Okay, so yeah, categorical. Okay, examples I'm just leaving this, some mathematics, and you know mathematics more than, right? Once we understand the formula, mathematics can be done. Okay, now there are ordinal attributes. What is ordinal attributes? We have the attribute values which have the ordering. Let's say one attribute is grade. So the grade values are excellent, A, B, C, right? So basically excellent, it is higher rating than A, and that is higher rating than B, and that is higher rating than C. There is an ordering, right? So let's say we have an ordinal attribute A with the values A1, A2, AN, right? And let's say they have the ascending order, A in the highest and A1 is the lowest. Okay, so what we do for this, we normalize these values. We normalize these values. Okay, so basically how do we do? Okay, let's say we give A1 is 1, A2 2, 3, 4, 5, 6, 7, like that, 1 to n we give, right? Then we normalize them using the formula. Let's say you A2, right? Let's say A2 is having the value 2. Okay, so we normalize A2 as 2 minus 1 divided by, let's say n is 10. N is 10. Okay, so it will be 2 minus 1 divided by n minus 1, 9. 2 by 9. Okay, it will be, it's a normalized value. So those normalized values we use in order to find out the differences, similar to the Euclidean distance over here, right? Let's say two objects are there, their categorical attribute, we take the normalized values of the categorical attribute, we take the difference, we square it, and we take the square root. This may give us the difference, the dissimilarity between the objects based on the ordinal attributes. Okay. Now let's say we have the numeric interval scale attributes, numeric. Most of the attributes we have the numeric, right? For our machine learning, we usually use, okay? So we calculate the distance, okay? So this Minkowski metric, it is very, very popular. It has a general form, given two objects, X and Y, okay? And let's say they have, each of them is they are in n dimensional objects, okay? So they have n attributes, right? So X is having the attributes X1, X2, X3 up to Xn. Y is having no, Y is having dimension. X is having yeah, attributes or dimension. Y is having the dimensions Y1 to Yn. Okay, so what we are doing is their corresponding dimensions. Okay, we are taking a difference of it, right? Then after that, we are taking it to the power, we are raising it to the power r, and then we are taking the rth square root of it. This is the general formula. Now the value of, when value of r can change, it can be 1, 2, 3. So as we change the value of r, a different name is given to it. So let's say the value of r is 1, then it becomes the Manhattan distance. It is also called L1 norm over here. So the Manhattan distance between the two objects is, what we do is we take the corresponding dimensions, we take the difference, and we keep summing them. Okay, Manhattan distance, this is also called the taxicals or city block distance. Okay, so an example is, let's say X has the dimension 735, Y 326. Okay, when we want to calculate the Manhattan distance, we are summing up the differences. So we are taking 7 minus 3 plus 3 minus 2 plus 5 minus 2, right? And we are taking the absolute value of it over here. So it comes out to be 6 over here. Hamming distance is a special instance of the Manhattan distance, where the attribute values are, they belong to 0 or 1, okay? So Hamming distance is the number of bits that are different between the two objects, okay? So this is one distance metric over there, popularly used. Another one of the most popularly used is Euclidean distance. Okay, it is called L2 norm. When you put r equal to 2 in the Minkowski distance, it becomes the Euclidean distance. So here we are having xi minus yi square, and then we are taking sum of all these component, all these differences, and we take the square root. This is the Euclidean distance. Okay, so for the same object, when we take the Euclidean distance, we get this distance over here. Then Chebyshev distance is there. This is also called L infinity norm. Okay, here this is basically we take the maximum out of all the dimensions, right? Whichever dimension produces the maximum difference, that we take over here in Chebyshev distance. For example, over here, let's say x and y we are having, right? So 7 minus 3 is right 4, right? 3 minus 2 is 1, and 5 minus 6 is again 1. It's a modulus value, right? So the maximum distance is between 7 minus 3, that is 4. So that will be the Chebyshev distance over here. Okay, so this is another. There are other metrics are there. The formulas are there, Cambria and Hellinger metrics. There are many others which can be used depending on the problem at hand. Okay, let's say we have the vectors. Okay, so we can find out the proximity, closeness between the two vectors, right? So we take the vector components. Let's say the components are a1, a2. Okay, so let's say we have two vectors si, two vectors x and y. Okay, so what we do is we find out the similarity between the each components of x and y, and we sum them. Okay, and we divide it by n. This way we can find out the similarity between the two vectors. There's something called cosine similarity. Suppose x and y, they denote two vectors representing two complex objects. The cosine similarity, that's cos xy, is given as dot product of x and y, and then after that the length of vector x, product of the length of vector x and vector y. It is over here. Okay, so cosine similarity can be used. Another is okay, this is an example of the cosine similarity. Okay, which I'm just going to the next. Then we can find out the correlations between the various objects. The correlation between two objects x and y, it gives a measure of the linear relationship between the attributes of the objects. So Pearson's correlation coefficient, this is very popular and it is being used. So correlation, Pearson's correlation between two objects x, y, it is given by Sxy. And what is Sxy? It is the covariance between these two attributes, which is given by this formula, right? We are taking the difference of each value of xy from the mean value of that particular variable, right? And each value of the other variable y from its mean, we are taking the product of it, right? And this we are doing for each dimension. We are taking the sum and then we are dividing it by the number of the values over there. Okay, so this we get the covariance. Similarly, divided by the standard deviations of x and the product of standard deviation of x and y. Okay, so this way we get the Pearson's correlation. So these are the, then this is an example of this. Okay, so basically this will give you an idea that how to find out the similarity and dissimilarity between the various objects. Okay, once we know this, so we'll be using one of these measures. After that, we need to find out the categories of the clustering algorithms. Okay, so let's go to this. So clustering methods, they can be partitioned into various categories. One is the partitional clustering. So given n data objects and you want to make k partitions of the data, and it is assumed that each cluster has at least one object. So each partition should have some object in that, and each object, it belongs to only one cluster. Okay, so we are creating the partition. Every partition, it is having at least one object, and every object, it is part of some partition. In partitional clustering. Okay, hierarchical clustering. The hierarchical clustering, we'll be taking this in more detail. Just I'm briefing. It starts with one cluster. So let's say you have 100 data items. It is all one cluster. Then you split it into the smaller cluster based on some criteria, right? You need to find out the some way to split it, okay, into the smaller clusters. So you keep splitting the cluster till we reach that single element clusters. Or the other way around, we consider each object as the individual cluster, and we try to merge the object which are very similar to each other. Okay, then that way we build the cluster and we keep merging the cluster in the form of an hierarchy. Okay, density based clustering. Here in density based clustering, each data point in a cluster, at least a minimum number of points must exist within its radius. So we create the clusters of the points, seeing the density of the points. Okay, so we make a point as a part of the cluster if it is in certain dense region. So this helps us to find out even non-spherical clusters also. Model-based clustering, basically the data is viewed as coming from a distribution model, a mixture of two or more clusters. Okay, so the probabilistic models, they are used to basically provide the distribution of the data. Okay, so it finds the best fit of the models to the data and estimates the number of clusters. Okay, then there is something called fuzzy clustering. Fuzzy clustering is a soft clustering method. What is a soft clustering method? The traditional clustering methods in that an object belongs to one class or one category. In soft clustering, an object may belong to multiple classes. Okay. See, in real world, many times it happens. Let's say we have, okay, temperature we want to classify. Okay. Cold or hot. We want to classify the temperature cold or hot. Okay. So for that, in the classical set theory, we'll have some boundary over there, right? Okay. Let's say I fix 25, 25 degree as uh, the boundary. Okay. So 25, less than 25, it is cold, and more than 25, it is hot. Okay. How about 24.9? Right? It is cold. Or 24.99, it is cold, right? And 25.01, it is hot. What is the difference between 25.01 and 24.99? It's very, very little. But this is part of hot set and this is part of the cold set. Okay. Fuzzy set theory, the objects, they are the member of a set with a certain degree of membership. So we can say that, okay, this 25.01, it is hot, but it's a degree of membership in the hot set is, let's say, 55% or 0.55. And it is also part of the cold set with the degree of membership, let's say 0.45 or 0.51 and 0.49, like that. Are you getting? So basically it's 0.51 cold and 0.49 hot, right? So soft clustering, an object, they may belong to multiple clusters with different degree of membership. Okay, so these are the various categories. Okay, now what are the desirable properties of the clustering? Okay, the scalability is one of the issue that we want the good time performance. It should not happen that as the size of the data it increases, the time complexity increases too much. Okay, and we should be able to work on different kinds of the data attributes, the categorical attributes, the numerical attributes, binary attributes, etc. then it should allow us in the discovery of the arbitrary shape clusters, not only the spherical always, but different kinds of clusters. Okay. We should also deal with the noise and outliers. Noise should not distort our cluster, right? It should not result in the discovery of the spurious or not real clusters. Okay. We should also be able to handle the high dimensional data. Then the clustering results should be comprehensible, right? Usable, interpretable. These are the desired cluster. How we perform the clustering? First, the question should be in front of us that what we want to do, what we want to categorize. Okay. Then we need to collect the relevant data. If required, pre-processing of the data needs to be done. Then clustering is performed. And after that, the clustering results, they're visualized, they're interpreted, and they're validated how valid the clustering is. Okay. So we want to use R for the cluster analysis. What is R? R is a programming software for statistical analysis, graphical representation, reporting. It has the effective data handling and storage capabilities. It provides suite of operators, calculate various data structures, arrays, lists, vectors, matrices. Okay. Various tools for the data analytics. Okay. Now you can perform the graphics and you can display them. Okay. It is one of the most widely used statistical programming language and one of the top choices for the data scientists for this. Okay. These days, among the programming language which are used for the data analytics, R and Python, they are the most popular. It depends on the people. Those who are already working with Python, they are more comfortable with the Python. This R is more compact, and usually the people, non-computer science people who are like in other fields also, they find it easy rather than with less programming to get the things done. So R is quite popular. Why to learn R? It is free and open source. It has more than 10,000 libraries. It is cross-platform. For statistics and data sciences, it is one of the go-to language. Okay. It supports the latest cutting-edge tools. So when the new algorithms they come, usually it's a library. It's open source. The support is provided for that. It is robust. Right? It has a good visualization tools and libraries. It has a large community of the user, and the R application, they are in almost all the industries because it's old language and for it is used extensively used for the data analytics. Okay. And there's a good job market also for this. It provides built-in lots of data. Some are listed over here. It has a built-in data sets. I'll just quickly tell you the installation of R, the steps in the installation of R, and I think after that we'll wind up. Okay, for the break, and then after that will be. So how to install R? Okay, simply you write download R in the Google. Okay, and you will be getting the link download. I think the first one, right? It will give the latest version of the R. When you click on this, after that it will take you to the R download page over here. Okay, so now whatever is the latest version, I don't know which one is now. Just a month back I think it was 4.0.2. okay, over there. So you click on that. Okay, so it will clicking will start the downloading the executable over here. You can see it down over here. Okay, once it is done over here, the download is done. It might have come to your download folder over there. Okay, so in the download folder you have to go over there and you need to double click on that the installable file over there. Once you do this, your installation will start. It will ask for you the language for the installation. Okay, I am keeping it to English over there. I press OK, and I just keep pressing the next over there. This the license is there. Okay, I just press next. Then it gives the directory. So I just keep the default directory for the installation. I press next over there. Okay, I just keep pressing next over here. Okay, yeah. Then do you want to customize? I just say no, default is fine for me. I just press next for this. Okay. Then okay, after that, if you want the start menu folder, you can click it. Otherwise, just press next over there. Okay. If you want to create a desktop shortcut, you can do that over there. Okay, press next. So it will start, right? So once the installation is finished, you will be getting this. Okay, so you can finish the installation by this. Okay. So this by installing this R, basically you install the R execution engine, R language execution engine you installed. But we want a good interface, the GUI, right? The IDE, integrated development environment. So for that, we need to install the R Studio over here. Okay, so how do we install the R Studio? For that, again, you Google R Studio over here. Okay, you click on the first, the rstudio.com, that link, right? It will take you over here, right, to the R Studio page over there. You click the downloads. After that, it will give you the various options, the free and paid. Okay, we want to go for free. So we'll click the free download over here. Then for various platforms, it will give you the executable. Okay, mine is Windows and Windows 10. So I'll select this, right? R Studio, whatever is the latest version, that exe, just click on that. So it's a download will start over here. Okay. Once it got downloaded, it will come into your download folder. Double click it. Installation will start. Just keep pressing next over here, right? I'm just keeping the default directory over here. Press next. Okay. So our studio is getting installed over here. Okay. So then when it finishes, it's basically the installation for our studio is over. Okay, fine. Okay, so I think this is now the break time. Okay, so we'll take the break now, and then after that, again after half an hour, we'll start with working with our studio, and then we'll start with the actual clustering algorithms. We'll be going through k-means and the other algorithms, and we'll try to run it on the R Studio. Okay, so we take this break. Hafiz sir?
Okay, thank you, sir. Dear participants, we shall now have a break of 30 minutes. We'll resume our session at sharp 11 a.m. with the second part of the morning session. And YouTube link will be shared with the Zoom participants also, so that you can just see the procedure to install the R and R Studio. Thank you. So welcome back participants. We shall now resume our session. I request Dr. Zahid Ansari sir to continue with the session.
Okay, thank you, Hafiz sir. Okay, I'm sharing my screen.
Yes, visible sir.
Visible? Okay.
Yes sir.
Okay. Okay, welcome audience. We are starting our next session. Okay, let's start with the R Studio. Okay, so when we want to use R Studio for the data analytics or data clustering, the first thing is we need to import our data files, right? So importing the data files, our data file can be in various formats, can be text, can be CSV file, can be Excel file. So it can be imported. Similarly, exported also. R provides excellent facilities for these. Okay. So let's say if we want to import some CSV file, there is a read.csv method for this. If we want to read an Excel file, read Excel method is there. Even you can specify the sheet number of the Excel file also to read to it. Okay. So all this you can do. Okay. Once we read it, after that, once we open the file, okay, we can store into a data frame. Okay. And it looks something like this over here. Our file, it's like a spreadsheet over here. The various rows and the columns, all those are seen over there. For after importing, you will see it in this way. All this will be seen. Okay. So once we imported our files in the form of a data frame is a data structure provided by R, which is very helpful for the data processing. Once you have your data frame, okay, you can create, rather than importing your data frame from a file, you can create your own data frame too. The details about the data frame you can get in terms of n calls, how many columns are there, n row, how many rows are there, dim, what is the dimension, names, what are the column names, if rows you have assigned the names, what are the row names. If you want to view it, then in that case, a view command is there. You want only the top few records, head command is there. Bottom few records, tail command is there. If you want to know the structure of your data, right, like about various columns in that data, about that and what few readings from the data, you can get it. If you want a summary of your data, like what is its a mean value, what is its a median, what is 25% quartile, 75% quartile, and all those, okay, this a brief statistical summary, you can use the summary method for this. Individual elements you can access, like array access over here. Even you can specify rows. Let's say you want only the row 1 and 2. So before comma, you can specify 1 column 2. Okay, like that. Similarly, you can specify the selective columns also over there. Okay, you can specify the column names with name also. You can get a subset also. Okay, so some of these will be seeing it. Okay, now, okay, once you have your data, right, you may need the data pre-processing. For any machine learning algorithm, right, the data should be in a form which is suitable to be operated by the algorithm which is at hand. You want to do classification, or you want to do clustering, or you want to do any other kind of analysis, whatever the form of input your algorithm expects, you need to convert your data to it. Okay, so usually we need to convert it to the numerical form. So when we do the data pre-processing, right, our data may have the missing values, right? So basically certain columns may not have the value. Age, let's say field for certain persons may not be there. Okay. Similarly, the other missing values, salary, some of them might not be there. Okay. So a common problem with the real world data is the missing values. One simplest approach is just to ignore the missing values. So pretend the data has fewer dimensions. Just don't consider those records with the missing values. Okay, but that may not be a very good solution. The more sophisticated approaches to estimate the missing values. Okay, let's say take the average of the column and replace it, fill the missing values by that, right? So you can impute the values for the missing values. Okay, and then okay, many times in your data there is a scaling problem for the various attributes. Okay, let's say you have some attribute salary, which ranges from few thousand to, let's say, up to million. Okay, so range is very wide. Okay, and let's say you have some attribute which has the value which is in a range which is in points. Okay, or let's say height, just few feet. Okay, or even some things which is in points. Then in that case, when you do the similarity or dissimilarity, where we are taking the differences between the attribute values, then those attributes whose range is very, very high, okay, their weight will increase because they will dominate to the similarity, dissimilarity values. We do not want that, right? Unless we want to weight our attribute based on some criteria, we can assign the weight. But ideally, we want the attributes to be rated equally, right? In normal cases. So in that case, we need to scale them in the range 0 to 1. Then again, there is a case, simple case is that divide each value by the maximum of that column. Then in that case, it will range, right? The maximum will become 1, right? And the others will be less than 1. A better approach is standardize using the this mean and the variance standard deviation, right? So R provides a method scale for that. We'll see some of the pre-processing also today. Okay, then to deal with the categorical data, as I said, the categorical data like color. Okay, color is a categorical data, right? The color values are there, various colors are there. Okay, let's say I have categorical data country. Okay, so country names are there. Okay, so now, but for this, our clustering algorithms, we need some numeric code for that, right? Numeric equivalent for that. So how to deal with them? So all these kinds of data pre-processing that is required. Okay, so just where we ended the previous session is we installed RStudio, right? So now I'll take you to RStudio and we'll see how to use RStudio, right? So you can click on the, if you have installed it, like the way to invoke it is that you can double click on the RStudio item and you can icon and you can get the application running. Okay, so now I am switching to RStudio. Okay, so I am stop sharing this. Then again, I'm sharing my screen to RStudio. Okay. Do you see the RStudio? Is RStudio seen?
Yes, sir. Yes, sir.
It's got shared. Okay, fine. Okay, so see, this is the RStudio. This is IDE, Integrated Development Environment. The integrated development environment, they make our life easy. Okay. Okay, let me clean it. I'll just do remove. Okay, list equal to ls. Okay. Okay. Yeah. Okay. So let's say we have opened the RStudio over there. There are 4 quadrants, right? So this, the top left quadrant, this here, we can open a R script and we can write the R code over here. Okay. The bottom right is the one which is console. Here again, we can write the R commands. Simple. Let's say I want to assign 2 to A, right? So I will do, right? If I see what is A, so A has the value 2, right? I can do 2 plus 2 over here. 2 plus 2. right? So this is the execution. This is the console where 2 plus 2, it is giving me the answer 4 over here. Okay. Now here I can open the script over here. Okay. So let's, for this, I will give 10 minutes, I think 10 minutes I will give for just quickly telling you that how to open a data file and perform certain operations on that and do certain visualization. I don't think we have more than 10 minutes for this, 10-15 minutes maximum for this. Before then we'll switch to the clustering algorithms. Okay. So I'm opening file. Okay, I already created. Okay, I'm let's say I'll be opening on the plant data set, iris plant. Okay, I have this, just I'll be showing on this. So I opened this file, right? Okay. Yeah, so you can see this is the R script over there. Okay, I'll be explaining some of them. Now you see, I created the variable A over here in the console, right? So you can see here in the global environment, A is appearing. So as you create the variable or create the functions, all those details, they are appearing over here. Okay. History will tell you the commands which you executed earlier. So I executed 2 plus 2 and all those, right? You can create a new connection over there. All those things are there. Okay. So if you want to see the files in various folders, that you can do. If you will do the graph plotting, that will come over here in plot area. If you want to install the packages required for R, because R's package library, it is very huge, more than 10,000 packages. Okay, so you need to load them, right? So not all the packages are over here. We only install the packages which we need. So you got some R code you are running and you came to know that it's a package or library is not there. So you need to install it. So for that, you click on these packages, then you click on the install button. Okay, then here you write the name of the package over there, and then you click the button on the install to install that particular package. Okay, right? So all this, and for any help you can go to our help over here, and this, even if you write the question mark, and after that you write the thing, let's say view or something over here. Right, so it will give you the help, invoke a data viewer. Okay, then how to use its a usage and all those things, it will come over here. Okay, so this is a brief introduction about the R Studio, how to use R Studio. Okay, now let me start. As I said that the R software tool, it provides you a number of inbuilt data sets. So what is the list of the data sets which are available with R? For that, you have the data command, this data. Okay. So I will run this command. How do you run this command? For that, see here, you see the run button over here. I will just click on that. I will select it, or I'll just keep the cursor over there and I'll run it. Okay. So it opened. See, here data sets, there is agriculture data sets, animal data sets, and flower data sets, and plant traits, and then so many data sets are over there. There's a big list of data sets is there. Okay, over there. So for your preliminary data analytics or clustering, you can find out a suitable data set. You can select from this and you can use it. Okay, so I am just closing this data sets window over here. Okay, so this list data, it give me just the data sets. Okay, if I want to know more about the data set, let's say I want to know more about the iris data set. Okay, so I can call use the view command, view iris data set. Okay, so this is the iris data set over here. Okay, so this is basically the flower data set. The flowers, they have the sepal and petal. So it is having sepal length of the various flowers. See, it is telling that now I am showing 1 to 11 entries, 1 to 11 of 150 entries. And there are 5 total columns, right? So there are 5 columns. There are 150 entries. Out of that, this 11 entries there over here. Okay. Now so you can find out that what are the column names over here: sepal, petal lengths, widths, the species of the flowers and all those. Okay, so I'll just close this. Now, okay, let's say I want to know how many columns are there. Okay, let's say I did not view it. I just want to know how many columns are there. So ncol command is there, right? So it is telling me, it is giving me 5. Okay, control L will clean my console. Okay, so if I ran ncol over here, so 5, right? N row, how many rows are there? 150. What are the dimensions? Okay, this 150 rows and 5 columns. Okay, names of the columns. Okay, so names of the columns are sepal length, sepal width, petal width, and species, right? Then head will basically give the top 6 records. If you give head comma 10, then top 10 records. I just give head. So it will give me the top 6 entries, tail, bottom 6 entries, right? Okay, structure of a data set. Okay, str command is there for structure of the data set. Structure. Okay, so it is giving that the column sepal length, it is numerical column number. Okay, and some of the sample values for that are 5.1, 4.9, like this for various columns. Okay, species column is a factor column. Okay, which has 3 levels: setosa, versicolor, and one more is there. Okay, and its values are like this. Okay, so the summary will give me the statistical summary about the data sets. For example, okay, let's see. It is telling me what is the minimum value for the sepal length, what is the maximum value for the sepal length, what is the median of this particular column, what is the mean or the average value of this column, what is the first quartile value, means 5.1. 25% of the values, they are below 5.1. What is third quartile? 6.4. So 75% of the values, they are below 6.4, like this. So for every column which are numeric, it will give like this. For a column which is not numeric, like species, it is telling that it will have, it has 3 values. Setosa, 50 values are of this category, setosa. 50 values are of this category, versicolor. 50 values are of this category, virginica. Fine. Okay, so you can get the summary. Okay, now let's say, okay, little bit more. From the iris, I want only the column sepal dot length, so I can use $sign, iris dollar sepal dot length. Okay, so it is giving me the value for the sepal length only. 150 values for sepal length, they are appearing over here. Sepal width, similarly we can do. Okay, now like array, like I want the value from 7th row and 2nd column, so I can simply do iris 7,2. Okay, if I do it, so that is 3.4 in iris in the 7 rows, and a 2nd column, the value is 3.4. Okay, let's say I want to change this value 3.4 to 5.2. Okay, so I'm assigning this iris 7.2 to 5.2. Okay, I did it. Okay, let's say I want to print it again. Now it's printing 5.2. Okay, I redid it to 3.4 again. Okay, so 3.4, yes, I changed it back. Okay, so okay, let's say I copied my iris data set into another data frame R. You can copy it, it's so easy. Now R will have everything what is in iris. Okay, and I want to edit R, so I'm giving the command edit R. Okay, so it will open this R for me for the editing. Right now I do not want to edit. So okay, if I want only the 3rd column, then I can specify a comma and 3. I want 3rd column value only. Before the comma, you specify the row ranges. After comma, you specify the column ranges. I have specified only 3 after comma. It means I want the column 3. So it will give me the value for the column 3. Okay. Okay. I want all the columns except the column 3. So I can give -3 over there, comma -3. Okay. So all the columns except the column 3 will come. Okay. Okay. Let's say this. So there are various things are there. Okay. I'll go to subset. Okay. Let's say I want only those entries for which the species is Setosa. Okay. And in that again, I want the first 5 rows. The first 5 rows of the species Setosa. So using the subset command, I'll be getting, see the I'm getting over here, and the this all these records, the first 5 records of the species Setosa. Similarly for versicolor, the same thing. Similarly for the virginica, same thing. Okay. Now let's do some data manipulation and let's say some graphic. Okay, maybe 5 minutes more I'll give for the visualization. Okay, so I have to include the library dplyr for data manipulation and ggplot2 for the data visualization. Okay, so I'm including these two libraries. Okay, I have the iris.csv file also to show you that how to import it. Right, I have the iris.csv file. I'm importing read.csv, iris.csv. Okay, so I imported it from my file. Now I can view it, view iris. So this is my iris file. Okay, now I'll try to show you some of the data visualization. Okay, let's say I want to create a very simple plot. I mean histogram I want to create from iris. So I'm using the command ggplot. Iris is my data set. In AES aesthetic, I need to define what is the x-axis for me. So on x-axis, I want to specify sepal length. So I want the histogram for the sepal length. I want to know the distribution of the sepal length. Okay. So for this, okay, let's say I'm specifying the bin width 0.1 and I want the purple color for my histogram. So I am running this command. Okay, sorry. This plot command I did not execute. Okay, ggplot. Let me execute this ggplot command first. Okay, so I created a plot for which I want to create the histogram. So plot plus geom histogram is the function which create the histogram. Okay, it is creating me the histogram of my desired color. I want to make it green. I will make it green over there. Okay. Maybe I want to add some more information to this, that I want to know that how is the distribution based on the species. So I'll be filling the color based on the species. Okay. So what I did is I added the aesthetic fill it by species. Okay. So now see, for each range, right, how is the division across various flower categories that I can see. Okay, you can draw the frequency polygon also. Okay, so see, frequency polygons are drawn about the distribution of the data for the various kind of the species. This is just a sample. I want to show that how the things you can do in R. Okay, so let's say, okay, area plot. Okay, so geom area is the command for this. Okay, you are doing the area plot. Okay, I want to fill it by species. Okay, yeah. So basically this is the area plot of the distribution of the sepal length. Okay. Now we'll go, okay, density plots also you can, the density distribution. Yeah. So see, this is the density distribution of the sepal length across various species. This you are seeing. Okay. Now I'll take you to, okay, let's say, we don't have much time. So for this, because we want to go for the clustering, okay, we want to, let's say, we want to take two variables now. Okay, x is sepal length and y is petal length. We want to see the correlationship between them. As the sepal length increases, what is the effect on the petal length? That we want to see, right? So I'm creating a ggplot for iris data set. In aesthetic, I'm specifying x is sepal length, y is petal length. Okay. And so I'm creating my plot using the ggplot command. Okay, plot got created. Visualization will be done when we use some geometric function. So I want the point was wise visualization for this. Okay, so I am doing this. Okay, so what I did is I specified the coloring should be done based on the specific. So it is giving me how the points are distributed. You can zoom it. See, if I click on the zoom button, you will be getting this nicely over here, right? So these points, they belong to the setosa. These green ones versicolor, this blue ones virginica, right? And more than this, let's say if you want to embed the this yeah, I'll just go the statistics to this. So let's say here what I did is a smoothing curve I want to draw at the top of it. Okay, and yeah, right, I want to give the colors to the points, all those. Even the quantile graph you can draw on this, where it will give the distribution. 25% of the point, they are below this line, the lower line. 75% of the points, they are below the upper line, right? And this is the median line, like this. So such nice curves. The frequency distribution for the various attributes you can specify. So let's say a species wise, you want to know how is the distribution of the sepal length using the box plot. You can draw the nice box plots for this. Okay, so see, it has drawn the box plot, and what it shows is like for each species, how is the sepal length, it is varying. This is the median value, right? This is 75 percentile, this is 25 percentile. The objects, they go up to this length, right? Anything, if outliers are there, they will appear over there as in the form of the dots. Okay, so you can draw the box plot. Similarly, you can draw the violin plots also for this. So let me draw how violin plot looks. Okay, I'll just show. They are like box plot, plus they also specify the density distribution. Okay, so this is basically the median. You can see how the density is the varying. Okay, so these are the basically the violin plots. The correlation among the various attributes also can be seen. For that, core plot library is there. Okay, so what I am doing is the correlation is between the numeric attributes. Okay, so I am separating out the attribute number 5, which is this species. So I am telling iris comma -5. Take the iris data set without the column number 5 and generate the correlation matrix for this by giving the core command. Okay, so I am running this core iris. Now I want to create the correlation plot for this. For this, the core plot command is there. Okay, see how it looks. I will just zoom it. Yeah, the blue colors, they are telling that these attributes are positively correlated. So see, sepal length and petal length, they are positively correlated. The darker is the color and bigger is the round, it means they are strongly correlated. Okay, and this the reddish kind of color, it is basically they are negative correlated. What is positive correlation? What is negative correlation? If the value of one attribute increases and the value of other attribute also increases, then they have the positive correlation. If one attribute value increases, other decreases, they have the negative correlation. And if they are not related, then in that case, it will be like this sepal length and sepal width, they are not correlated, because here it is a very little negative, almost not. Okay. If you want this in the form of number, you can specify method equal to number. Then it will give you the figures over here. Yes. So sepal length and petal length, they are positively correlated. And see, the correlation ranges from -1 to +1. So it is +1 side, 0.87. They are highly positively correlated. Okay. And these two, they are very like almost not correlated, right? And this is also highly correlated, petal length and the petal width, they are highly correlated. Okay, so correlations you can find out, right? Correlogram is also very similar to the correlation plot. Okay, so this again gives the correlation between, see, ascending lines show the positive correlation, descending line and the different color shows the negative correlation over here. Okay, similarly heat maps are there. Heat maps, I'll just show how does it look like. It also shows the correlation only. Okay, so this is the heat map. Okay. So I took this much time over here just to tell you that various kinds of visualizations you can do using R. Okay, now I'll close this file now and I'll switch back to this our this PPT partitioning. Okay, we'll start with the partitional clustering algorithm because our topic is clustering, right? I'm closing this, both the data set. Okay, now I will just stop sharing this and then I'll share my PPT. Okay. Is the PPT visible?
Yes,
Is
sir.
the-
Yes. Yes,
Okay.
yes.
Okay. So the agenda for session 2, although some part I have code, let's see how much. Partition-based clustering, in that k-means clustering, k-medoids clustering, then different variants of k-medoids clustering, Pam, Clara, Clarence, I don't know, all these, Pam, Clara, definitely, okay. Then k-Morse clustering, I'll quickly touch it. Then how to find the number of clusters, right? One of the problem is in all this partitional clustering, we need to find out how many clusters are there. We need to guess it. We need to estimate it. So how to find the number of clusters, that we'll see. Okay. Then fuzzy C-means clustering is a fuzzy clustering, right? If time permits in this session itself, we'll try to cover this. Okay. Then after that, let's clustering methods we saw, right? We are going to for the partitional clustering. So partition based clustering. Okay. So in the partition clustering, as we discussed, given n data objects, we make k partitions of the data object. It is assumed that each cluster has at least one object and each object belongs to only one cluster. Okay, so there are non-overlapping clusters. Clusters, they do not overlap. Every object belongs to a single cluster. Then we need to specify the desired number of the clusters, k. K we need to specify, right? So a set of object, k is 2. So let's say it has been partitioned into 2 clusters of the objects, okay? So the partition-based clustering, its objective function is, while partitioning n objects into k cluster, we want to optimize the partitioning criteria. What is the partitioning criteria? We want to minimize the sum of the squared error. What is the sum of the squared error? Okay. In the clustering, when we form the cluster has a center. Okay. So let's say we have a cluster Cj, which has a center small cj. Okay. And in this cluster Cj, there are various point x, which belongs to Cj. So we add up the distance between each point and the center. We measure the distance between each point and the center. We square it up and then we add it for each point, and this we call sum of the square distance. Okay, so this is for every cluster we do, right? So when we combine these distances for all the k clusters, let's say there are k clusters, then we get SSC, sum of the squared error for the whole clustering. Okay, so this sum of the squared error we want to minimize. What is the meaning? If the clusters will be compact, then all the points in the clusters, they'll be very close to the center. Okay, so the sum of the square distance, that will be minimum, and that, so we want to minimize it. Okay, so okay, let's see over here. Let's say this is a cluster. We have 3 points, x1, x2, x3. Their center is Cj. Let's say their coordinates are there. So the cluster Cj, it consists of x1, x2, x3. Okay, x1 has the coordinate 3, 7, x2, 2, 3, x3, 7, 5 under this coordinate axis. Okay, so let's take the let's calculate the sum of the squared error, right? So that the distance between x1 and Cj, it is given over here, as per the formula, it is 5. The distance between x2 and Cj, as per the formula, it's 8, and between x3 and Cj, it is 9. Okay, sum of them is 22. So here the sum of the squared error is 22 in this case. Okay, if we compare this clustering with this clustering, where the points x4, x5, x6, they are closer to Cj. Okay, so their coordinates are given. If we calculate the sum of the square error, it comes out to be 3, right? So this is much less than, right? Much less than the earlier figure 22, right? So this is the better clustering. So we want to minimize the sum of the squared error in case of partition-based clustering. Is this clear? Okay. Now, okay, let's say we have the endpoints and we want to partition them into k clusters. Okay, so this can be done in k to the power n possible different ways. If we take all the permutation and combination, in order to find out the best one, there are k to the power n possible combinations, right? It is too expensive for us to do it. Okay, so we use the heuristic methods, k-means and k-midwives. In k-means method, when we create the cluster is represented by the center of the cluster called centroid, which is calculated, which is the average of all the points in the cluster. So the center is not a data point in case of k-means cluster. It is calculated point. It is a calculated point or calculated object, right? In the in that space of the in that data space. Okay. In case of key midwives, each cluster is represented by one of the objects as its midwives. So basically, every cluster is represented by the most centrally placed object in that particular cluster. So what is the difference between k-means, k-midwives? K-means center is an imaginary point, and k-midwife center, it is a real data object, which is the most centrally placed object in that particular cluster. It will be clear from further. So we go for the k-means clustering. Okay. How does the k-mean clustering works? So we want to create the k partitions, right? So we need to decide what is k. We want 2 partitions, 3, 4, 5. So decide on the value of k, right? Then initialize k cluster center. So the clustering starts by choosing the k cluster centers. Okay, so out of the n objects, we can randomly pick k data objects, and we tell that this object is the first cluster center, that object is the second cluster center, and that object is the third cluster center. Or through the random number generator, in that range we can generate 3 points, whatever. Okay, either pick the data objects as the center or randomly through the random number generator, you create 3 points. Okay. Now, after that, once we have the center, so these centers, we attach the points to them. So depending on the points, if the point is closer to the first center, it will go into that cluster. If the point is closer to second cluster, it will go to that cluster. If the point is closer to the third cluster center, it will go to that. Okay. So we calculate the distances between the data objects and the k centroids, and we assign the object xi to the cluster center which is closest to it. Okay. Now example is there. Okay. Now you look. Okay. Let's say we have a cluster over here. These are the two clusters over here. Okay. Now, okay, let's say two clusters we want. Okay, randomly we said that these belongs to one cluster, this belongs to one cluster. Okay. Now we need to calculate the center of this particular cluster. Okay. So how the center is calculated? Center is calculated over here. We take the mean of all the dimensions. So let's say these are the 2-dimensional data. So we add up the first dimension of all these points in this cluster. We divide it. How many points are there? 6 points are there. We add up the first dimension divided by 6. Whatever is the value, that is the first dimension of the center. Then we take the second dimension of this. We add up the second dimension values. We divide it by 6. We get the second dimension of this. So this is the center. Okay. So here we got the 2 centers for the cluster. Okay. Now once this is the center, after that, once we computed the center, so we earlier said that this blue point, this is part of this cluster. But after the center calculation, we find out that this data object, it is more close to this cluster center than this cluster center, right? So what we do, we take this object, we assign this object to this cluster. So see, in the next iteration, what happens? This object has been assigned to this cluster. Similarly, this object earlier, we said it is part of this cluster, but now after the calculation of the centers, okay, it came out that it is more closer to the other center. Okay, so this point got shifted to this particular cluster. Okay, now once we did it, so now this is another one cluster, this is another cluster. So after that, since the points got changed, we need to find out their center again. So we are taking the average of these 6 points now, and we get this cluster, this center. And we get the average of these 4 points now, we get this cluster. This we keep repeating till there is no change. Okay, maybe it will be clear, more clear over here. So see, we have all these points over here. Let's say our distance metric is Euclidean distance. Okay. And now let's say through the random number generator, we generated 3 points, K1, K2, K3 as the 3 cluster centers over here. So now we need to find out which points are closest to K1, right? I mean, for every point, for every data object, we want to know which is the closest cluster center. Okay. So when we do it, so we assign those objects to that cluster. Okay. So this has been done. We found that all these green ones, they are closest to K1. These red ones, right? They are closest to this, and this purple one, they are closest to K3. Okay. So once we form the cluster, so K1 was an imaginary, this thing, the cluster center, right? Centroid. We need to calculate the actual centroid of it, right? So when we calculate the center for this cluster, center for all these clusters, then it comes out to be that the center is somewhere here. And for this, the center is here. For this, center is here. So we do that. Okay. So the center is this. Okay. When this becomes center, okay. Yeah. Now you see, Okay, just a minute. Yeah. See, when the center got shifted to this point, okay, and this center got shifted to this point, and this center got shifted to this point. After this center got shifted to this point, this object, the green one, which was earlier associated with K1, now it will be more closer to K3. Similarly, after this center K1 is shifted over there, now this object, it is more closer to K2. So when we do this, we calculate the center, see the objects, they got changed over there. Okay, so this green one, this it came here, and this green one basically it went over here. Yeah. So after that, we need to recalculate the centers. So we recalculated the center, okay, because there was a reassignment of the data objects. Okay, so because of that, the centers, they got shifted again, right? We keep doing this till the points, they do not change, right? A demonstration of k-means clustering, 2 clusters. If we are going for 3 clusters, it will work and it will form 3 clusters. 4 clusters. 5 clusters. Right? Okay. Yeah. Okay. So I'll move to the next slide. Okay. What are the strengths of k-means method? It is relatively efficient for the larger data sets. The time complexity is of the order of big O of TKN. What is N? The number of objects. What is K? The number of clusters. What is T? The number of iterations. Like how many iterations were required for the k-means clustering. Okay. So usually this K and T, they are much smaller than the N. N is the number of objects. Okay. So basically it's quite good. Okay. Then often terminates at local optimum. Okay. We can say this is merit or demerit, local optimum. Okay. The result may not be the global optimum. For global optimum, maybe we have to use some other heuristic or the evolutionary thing, genetic algorithms. I myself have worked on the k-means using genetic algorithm during my PhD, okay, in order to get a better solution. Okay. Weaknesses of the k-means method. Okay. Unable to handle noisy data and outliers. What is the meaning of it? Noisy data and outlier. Okay, maybe somewhere here I have. Yeah, okay. Let's see. Let's see, you have the data points over here. See these 4 data points, then these 4 data points, and there is one. Okay, okay. And let's say you want to form 2 clusters. Your K is 2. Okay. Let's say if this data object is not there, this data object is very different from the other data object, right? So we'll say this is outlier. This is exceptional case, right? If it is not there, then we may get the 2 clusters. One is this cluster and another is this cluster. But because of this outlier, finally the k-means resulted in 2 clusters, and one cluster consisting of these 2 points and the other cluster consisting of this point. So basically it is sensitive to the outliers. We get a very different result when the outliers are there. Okay. So this is one of the drawbacks of the k-means clustering. So what we do is, in that case, why this happens? Because the centers what we choose, they are the imaginary in case of the k-means. The k-means clustering, it is a solution for this. Here always the centers are one of the object, and we pick the object which is the most centrally placed. The object which we pick, which is the most centrally placed. Okay, so in that case, this the effect of the outliers are not big as this, because outliers are not the centrally central objects, they are the border objects. Okay, so they are not picked as the as the amidoids. Okay, so the effect of outliers is very less. Then for k-means algorithm, we can do the k-means where the mean calculation is possible. The numerical attributes are there, right? It doesn't work with the categorical attribute. So one way is the categorical need to be converted to some numerical equivalent. That is one solution. Okay, if you do not want to do that, then for that one option is the k-modes algorithm is there, that I'll show now quickly. Okay, then but one problem still persists with these partitional clustering algorithms is that they need k to be specified, number of partitions. Okay, so there is a way to find out how estimate the number of partitions that we'll see, but there are clustering methods for which you need not specify the k initially to work with. One is hierarchical algorithm, the other is density based algorithm. K is not required. Okay, so they are the solutions. So this is some of the discussion about this. I'll quickly tell about the k-modes algorithm, and I think after that, before going to k-medoids algorithm, I feel that I'll go take you to the R studio and we'll see the working of how in R how to invoke k means, that we'll see. Okay, I'll just tell k modes algorithm. When k modes method is used, I said that when you have the categorical attributes. Okay, so let's say you have the categorical attributes: income. Income is high, medium, low. With student, yes, no. Credit rating, fair, excellent, etc. And the age, less than 30, between 30 and 40, greater than 40. Right? So these are all categorical attribute, right? So K means you cannot apply to them unless you convert it to the numerical values. Okay? But you can use the K-modes algorithm. In K-modes algorithm, whenever you have the data points and you want to select it's a center, there, rather than finding out mean as the center, you take mode as the center. What is the mode? So we are replacing mean of the cluster with the modes. Given n records in the cluster, mode is the record made up of the most frequent attribute values. Okay, so let's say this is a cluster. These objects, they belong to a cluster. How you will find it's a center? It's a center is mode. So I'll take in age, which is the value which is the most frequent. So I see that less than or equal to 30, it is appearing most frequently over here. So for this dimension age, I will choose this value, the most frequently occurring value, less than or equal to 30. For income, what is the most frequently occurring income? I think that is median, 1, 2, 3, 4, 5, right? Median. So I am taking it median because median is the most frequently occurring. Student, yes or no? Yes is more than no. So I am taking yes. Credit rating, fair, excellent. Fair is more frequent, so I'm taking fair. So now the center is this particular object. Okay. So the same algorithm you can run, but for the calculation of the center, rather than taking the mean here, you are taking this, the mode over here. Okay. Yeah. So let's go to our studio now. Okay. I think I'll first show you how to do the data pre-processing little bit, and then after that how to run the this k-means algorithm. Okay, yeah. So I am going to R studio. Yeah, I'm stop sharing this. Sharing. Okay. Yes, our studio is shared.
Visible, sir. Yes, sir. Yes.
Okay. Okay. Now let's do the data pre-processing first. Okay. Then after that, I'll show you the demonstration of k-means. Okay. So I'll just clean Control L for this. Even I don't want these variables, so I'm removing them. The remove command list. ls gives me all the variables, so I'm just deleting all the variables from here. Okay, even I'm deleting this graph also. See, this is to delete. See, I can export this graph through the export. I can save as image, I can save as PDF, I can copy it to the clipboard. All those things I can do with whatever graphs are getting generated. Okay, I can delete this by this button. Okay, I delete all the graphs. I can delete it through this symbol. Okay. Okay, it's a clean now. Okay, let's work on the pre-processing, right? So as I said, we'll be doing three kinds of pre-processing. We'll try to remove the noises, or we'll try to replace the noise means not sorry, not noises. I'll say that the NA, the missing values. Okay, we would like we'll try to discard the missing values. Then we'll try to replace the missing values. Okay. Then maybe we'll try to transform the values into the uniform range. Okay, or we want to we will scale the values, and we'll try to convert the categorical value into the numeric values. Okay, these 2-3 things we'll do in the pre-processing. Okay, so let me open. So I'll open the file. I have created a file called preprocess.r. Yes, R files, they are basically they have the extension .R. Okay, so I'm opening this preprocess.r file. Okay, I'm going to the beginning of this file. Okay, yeah. Okay. See, I am using a data set customer.csv. I have a CSV file. What is CSV file? Comma separated file. Okay, customer.csv, which has the some information about the customer. Okay, so this file even has the missing values also. Okay, so this we want to pre-process it. In order to open this file and load into a data frame in R, we are using the command read.csv. Okay, and we are specifying the name of the file, customer.csv. Okay, now in order to tell that which is the directory, what is the working directory, there is a set working directory command over here. Okay, here I am specifying that my data file is in declustering FDP R code. In this file it is there, right? So I am just setting the working directory to this. Then I am reading my CSV file into this data set. Data set is the name of a variable, is the name of the variable. Okay, sorry. Okay, I selected it and I ran the command. So it is telling me that data set not found. I should not select it. Okay, either I should select this whole line and I should run it. Yes, so it ran this command, right? Or I should just put the cursor over here and I should this command again. So it read this file into data set. Whether it has read or not, see on the right hand side in the global environment, you see the data set over here. So it is the data frame. What it says, 15 observations, meaning is there are 15 records, 4 variables, there are 4 columns. Okay, if you want, you can double click on this, so the data set will be open. This is the customer data. nation, the country, the nationality, or the nation of the customer, right? India, Russia, Germany. We only 15 records. Okay. This is an artificially created data set. Okay. Okay. Age. Okay. So age is given. See, there are some entries where you see NA. It is basically the missing values. NA is missing values, not available. Okay. Then salary. In salary also, there are few records where the salary is not there. Whether this customer purchased the item, yes or no, that is there in these columns, right? So you see age and salary, these are the numerical, they have the numerical values. And nation and this purchased item, they are the categorical value, right? The nominal attributes which have the name, they have the categories in this. Okay. So, okay, I close this. I go back to pre-process. Okay. Let's say I want to know the column names. So nation, these are dimension, head, tell. A string will tell me structure. STR is for structure. It tells me that the first column is of type character values it has. The second and third, age and salary, they are integer ones. And the purchased item, it is again the character. Okay. Summary will tell me for the numerical attribute, it will tell me their mean, max, and all those. Okay, fine. Here we are more interested in checking if the data set has the missing values. So since we already viewed the data set, we know that there are missing values, but we can check it by the command is.na. Is not available values are there in the data set. Okay. If I run this command, then for every value, it will tell me yes or no. It is available or not available. Okay. So if I run this on the data set, is.na data set, then see, I got here this output. For the values which are not available, it will give true, and for the available values, it will give false. So it is basically the Boolean values it is having. It is a structure with the Boolean values, whether n is yes or no. Okay. Now, let's say I just want to know total how many the true values are there. So I'm calling the function sum. Give me the sum of all the truths. Okay, so I'm calling this. So it is giving me that total there are 6 values. See down the result 6. 6 is the result. There are 6 missing values are there. Okay. Now I want to know what are the missing columns. Okay. So what I do is I apply this any NA. Any NA is a function. Is there any NA? Any missing value in that? So I am calling the apply function to the data set over here to the columns. But this I want to apply only, yes. Yeah, from that I want to, okay, let me run it one by one. I am applying apply method I am calling on the data set. Is there any, give me the columns with the, with 2 is for the columns which are having the missing values. Okay, so I run this. So it is giving me that for nation, it is false. Nation does not have missing value. Age, it is true. Salary, it is true. And purchased item, it is false. Okay. I just want the names. Okay. So I am doing call names from this. So I do this. So basically this variable call missing variables, it is having the names of those columns which are having the missing value. If I print this, so then I'm having the columns with the missing values, age and salary. Okay. Okay, I'm using the library dplyr, okay, for the manipulations. Okay. Let's say I want to omit the value. The simplest solution for the missing value is just omit them. Okay. Just omit those values. Okay. So I'm calling the data set this percentage greater than percentage. This is a pipe operator. pipe, in Unix, there's pipe. The output of the previous command, it goes to the next command like that. So data set is an input to na.omit. So we are telling that take the data set and omit those rows which are having the not available values. And the result you put in the data set omitted, put the result in data set omitted. Okay. So if I run this command, data set omitted. Okay. Now, if I see the dimension of data set omitted, okay, see, it is telling that 9 rows and 4 columns are there. See, data set, it had 15 rows and 4 columns, now 9 rows, because the 6 missing values were there in 6 different records. So now we are getting the data set omitted. If I open it, let's say I double click on this. So you see, some records, record number 2 is missing over here, row number 2. Okay, row number 4 is missing. Similarly, 7, 8 are missing, right? 10 is missing, like that. The one which the missing values, they are omitted over here. Okay, so just okay. Yeah, but this is not a very good solution, right? What we want, maybe we want that we want to take the mean of, and we do it. So we use again the apply method. And what we are telling that from the data set, the columns which are in the column missing values, means in column with the missing values, there are 2 columns, right? For all those columns which are in column missing values, okay, find out the mean. And while calculating the mean, okay, you do not consider the not available value. So na.remove equal to true. While taking the mean, you just remove the missing values and take the mean of that value. Okay, and give me the average of the column averages for those 2 missing columns. Okay, so when I run this command, okay, I get the average missing. Okay, if I print it, see, it is telling me that the age is having the average value 39.58 and salary is having the average value 51,000. This is the average value, right? See, I'm using mean over here, right? I can use mode also over there, right? Median also I can use over here. I can use the median also over here. So let me use the median, okay? I'll just use median over there, and then I'll change it back, okay? Median, okay? So median is there, okay? If I run it, right? And if I print it, see, now we got the median. Median is 38.5, mean was 39.58, right? And the median salary is 53,000. And the mean salary was 51,000. So whatever you want, okay, that you can, I'm again changing it to the mean. Okay, so I'm taking the average value. Okay, I'm running, right? So I got this, right? So from this, in order to extract the average age, I'm getting the first element. So I'm taking from average missing the first value, I'm storing in average age, and the second value I'm storing in average salary. So I'm getting average age and average salary. Okay, this I got. Now what I want to do in the age column, right? So basically in the data set, if we see still in the data set, right, we have the not available values are there. So this not available, we want to replace with the average what we have calculated just now. Okay, so what I am doing is I am using if else function of R, right? I am telling if the value that in the data set age column, if the value is not available, then in that case you replace it with the average of age, right? And if that value is available, I mean, if this first condition is false, then in that case you keep the same value. Otherwise, and if is not available, if it is true, then you replace it with the average value. If I run this, so this I am doing for the age, and similarly I am doing it for the salary. Okay, so I'll run this for both of them, and after that we'll see the data set. Now see the data set. See, the missing values, where the missing values, those have been replaced with the average value. Okay, and similarly the salary, wherever it was missing, it has been replaced with the the average value. Okay, so this we imputed the missing values by taking the average. Okay, so this was the basically the missing value processing. Now, yeah, one more thing you see in the data set. Now, since we took the average, so age which was earlier without the decimal points, now it is all coming with the decimal points because we took the average of it. Okay, so we want to transform it back into without the decimal point, right? So for this, yeah. Okay. Yeah. Before I do that, first I want to see whether the age column it is having any of the missing values now. So I'm calling the function sum on it. It's giving me 0, no missing values in age column. Similarly, are there missing values in salary column? I'm doing this, no missing value in the salary column. Okay. Now, okay, now what I am doing is I want to transforming, I'm rounding off my age to the, I want 0 decimal point over there. So I'm using this round function. I'm formatting as numeric age. Okay, so because I do not want the decimal point over here. Okay, if I display age over here, now it got converted to 25, 40, 50 again, no decimal points now. Okay, now the next thing. Okay, let's say we want to do the attribute scaling. As I said earlier also, that what is the meaning of scaling? If we have the different attributes and they have the different range, some attribute has a very high range, some attribute has a very low range, then when we do the clustering, since the clustering is based on the calculation of the dissimilarities, if the range variations are very different, then one of the attribute will dominate on another attribute, and that we do not want. So we want to scale all the values between 0 and 1. So one way is that you divide every value by the maximum. For example, okay, let's say the data set, okay, among the age, what is the maximum age you find out? Okay, maybe it's 63 over here. So divide all these values with 63. So 63 will become 1 and rest all will be between 0 and 1, right? Similarly, find out what is the maximum salary over here, okay, and divide it by the salary value. Okay, fine. That way you can do it. So if we do it, it is very simple. Okay, I'm not actually replacing the column. I'm creating another column age over here. Okay, not in the data set. And what every value of the column, I'm dividing it by the maximum from this the column, okay, by this command. Okay, so now if I run it and if I print, see, so see it converted age. Age is I created one vector over here, age. It is having the value which is all between 0 and 1. Okay, a more better solution is if we scale. What is scale? Scale is a function provided by R. What it does is it takes the mean of each column, it subtracts the every value from the mean, and it divides it by the standard deviation. So basically we get the scaled values. Okay, so if we do that, then so let's say what I did is I want the scaling to be performed only on second and third column, because second and third columns are numeric. So I am selecting only second and third column. So on second and third column, meaning is on age and salary column, I want to apply the scale function. If I do this, right? And if I see my data set over here, so my data set got scaled over here. See, salary and age, all these got scaled over here. Okay. Now, okay. Now the last part of the pre-processing before I take you to the k-means is, okay, categorical attributes. So we had the attribute nation. Okay. So this nation, it is having three nations, India, Germany, and Russia. Okay. R provides you a data type or a function factor in which you can specify the numeric code for them. Okay. So I'm taking the dataset nation, which has three labels, India, Germany, and Russia. For them, I'm specifying the labels 1, 2, 3. 1 for India, 2 for Germany, 3 for Russia. Similarly, for the purchased items which had the values no and yes, I am providing the numeric labels 0 and 1 using this factor function. If I run this command, okay, and if I see the data set, my data set over here, see it has substituted 1, 3, 2. So 1 corresponds to India, to like Russia and Germany, they correspond. Yes, no, they have become 0, 1. So now they are all numerical. So now you can perform the various kinds of the machine learning algorithms you can apply to them, right? Similarly, if you want, let's say, rather than converting the values to 1, 2, 3, if you want the multiple columns for the nation, let's say you want it this way, that since there are three nations, okay, so you want to convert it to three columns. One is column India, nation India, another is nation Russia, and another is nation Germany, the binary columns. So whichever is the nation, for that the value will be 1 in that particular record. For all other nations, the value will be 0. For that, there is a function called toDummies. For that, I need the library var handle. I'm running this. I'm converting this. Okay, I'm using this DS. Let me have DS. DS, I copied my data set to DS, and I'm using DS over here for this particular operation. I do not want to touch my data set. So I'm using DS over here. Okay. So on that DS, I'm applying toDummies, and the output I'm taking in binary nation. Okay. Right. And now after that, if I see the binary nation, you see it created three columns, nation.1. It is has the value 1, 0, nation.2, right? Nation.3, it is having the value like this. Okay, fine. Yeah, so this was all the pre-processing, right? Okay, let me quickly 12:13. Okay, Hafiz sir,
Sir,
uh,
what
shall
to do,
we
sir?
continue after the lunch now?
Okay, sir, as you wish.
12:30. Oh yeah, I think I'll be starting K-means clustering after this. Okay,
Okay, sir.
this in the afternoon session. Okay, we'll take a
Okay.
break now.
Okay, thank you, sir. Dear
Okay.
participants, we shall now break for lunch and will resume at sharp 2 p.m. to continue with the afternoon session by Dr. Zahid Ansari, sir. I request all the participants to mark their attendance using the link shared in Zoom and YouTube chat window. Kindly join the afternoon session before 1:45 p.m. Thank you.
Upload करते तो